Thank you for joining another math lesson hosted by Book&Table. I am your math tutor, Maurice Wright, and in this video, we're going to complete practice set number 1 to our complex numbers chapter. You will have a chance to practice the equality rule, adding, subtracting, multiplying, and dividing complex numbers. We'll work with factoring polynomials that lead to complex roots. And then we'll wrap up the practice set with graphing, including graphing complex numbers and calculating the modulus and the arguments in each of the 4 quadrants. Should you have any follow-up questions, feel free to leave them in the comment section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Question number 1. Solve for x and y, check the answers. X plus 3 plus y minus 2i is equal to 5 minus 9i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, set the real numbers equal to each other. So on the left side, x plus 3 is the expression that represents our real number. So we'll put that on the left side here. And on the right side, 5 represents our real number. So we'll put that on the right side here. And now we want to solve for x. So we'll subtract 3 from both sides. 5 minus 3 shows us that x is equal to 2. And now that we've solved for x, let's go ahead and solve for y. So the third step, set the imaginary numbers equal to each other. On the left side, y minus 2 is the expression that represents our imaginary number. And on the right side, negative 9 represents our imaginary number. So we set y minus 2 is equal to negative 9. And now we'll solve for y by adding 2 to both sides. Negative 9 plus 2 shows us that y is equal to negative 7. And now that we have our values for both x and y, the last step is to check the answers by plugging them into the original equation. So we'll plug in x is equal to 2 for x. When we do, we get 2 plus 3, that's equal to 5. So the real number on the left side matches the real number on the right side. So that confirms that x does equal 2. And y, we plug in negative 7 for a y here, giving us negative 7 minus 2, which would be negative 9i. So the imaginary number on the left side equals the imaginary number on the right side, which confirms that y does equal negative 7. So since the left side equals the right side, that confirms that x equals 2 and y equals negative 7. Let's take a look at question number 2. Solve for x and y, check the answers. X minus 7 plus negative y plus 4i is equal to 11 plus 6i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, set the real numbers equal to each other. So that would be x minus 7 on the left side is equal to 11 on the right side. And now to solve for x, we'll want to add 7 to both sides of the equation, giving us 11 plus 7, which is 18. So we get x is equal to 18. And now for the imaginary values, you set the imaginary numbers equal to each other. So that would be negative y plus 4 is equal to 6. And now to isolate y, we'll subtract 4 from both sides. giving us 6 minus 4, which shows us that negative y is equal to positive 2. And now to get positive y, we'll want to multiply both sides by negative 1 to get rid of this negative coefficient here. So by multiplying both sides by negative 1, we get negative 1 times negative y, which is y. And on the right side, we get 2 times negative 1, which is negative 2. So we get y is equal to negative 2. And now we can check the answers by plugging them into the original equation. X minus 7 plus negative y plus 4i is equal to 11 plus 6i. We'll check the real number first. So we'll plug in 18 for x here. That gives us 18 minus 7, which gives us positive 11 as our real number on the left side. And that matches the real number on the right side, which confirms that x does equal positive 18. And now for y, we'll plug in negative 2 for y here, and that would give us negative 1 times negative 2, which would be positive 2, plus 4 would give us positive 6i. 6i on the left matches 6i on the right, which confirms that y does equal negative 2. So the answer to question number 2 is x is equal to 18 and y is equal to negative 2. So that is the answer to question number 2. Let's take a look at question number 3. Solve for x and y. Check the answers. 2x plus 3 plus y plus 5i is equal to 17 plus 2y minus 2i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, set the real numbers equal to each other. So the expression on the left side that represents our real number is 2x plus 3. And on the right side, we have a real number of 17. So now that we've set those equal to each other, we want to solve for x. So we'll first get rid of the constant positive 3 by subtracting 3 from both sides, leaving us with 2x is equal to 17 minus 3, which is 14. And now to get rid of this coefficient of 2, we'll want to divide both sides by 2. 14 divided by 2 shows us that x is equal to 7. And now to solve for y, you'll want to set the imaginary numbers equal to each other. So that gives us y plus 5 on the left side. And that's equal to 2y minus 2 on the right side. And now we want to solve for y. So the first thing we'll do is subtract y from both sides. That will negate this y, leaving us with just y on one side of the equation. So that leaves us with 5 is equal to 2y minus y, which is y, minus 2. And now to solve for y, we'll add 2 to both sides. 5 plus 2 shows us that y is equal to 7. And now that we've solved for x and y, we want to check the answers by plugging them into the original equation. So we got x is equal to 7, so we'll plug that in for x here, giving us 2 times 7, which is 14. 14 plus 3 is equal to 17. The real number on the left side matches the real number on the right side, confirming that x does equal positive 7. And then you plug in 7 for y here and here, leaving us with 7 plus 5i, which would give us 12i on the left side. And on the right side, we have 2 times 7 minus 2. 2 times 7 is 14. Minus 2 would give us 12i on the right side. So since the imaginary number on the left matches the imaginary number on the right, that confirms that y is equal to 7. So the answer to question number 3 is x is equal to 7 and y is equal to 7. Let's take a look at question number 4. Solve for x and y. Check the answers. X minus 6 plus 13 minus yi is equal to 10 plus 2y plus 4i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, set the real numbers equal to each other. The expression x minus 6 represents our real number on the left side of the equation. And on the right side, we have a real number of 10. So x minus 6 is equal to 10. So we solve for x by adding 6 to both sides, giving us x is equal to 10 plus 6, which is 16. And now we'll want to solve for y. So we set the imaginary numbers equal to each other, which would be 13 minus y on the left side. And that's equal to 2y plus 4 on the right side. And now we want our y's on one side of the equation. So we could subtract 2y from both sides, or we can add y to both sides. We'll add y to both sides, giving us 2y plus y, which is 3y. So now we have 13 is equal to 3y plus 4. So we first want to subtract 4 from both sides so that we can wind up with just 3y on the right side. 13 minus 4 is equal to 9, which is equal to 3y. And now to solve for y, we want to divide both sides by 3. So that would give us 3y divided by 3 is y. 9 divided by 3 would give us 3. So we get y is equal to 3. And now that we found x and y, the last step is to check the answers by plugging them into the original equation. X minus 6 plus 13 minus yi is equal to 10 plus 2y plus 4i. We'll plug in 16 for x here, and that gives us 16 minus 6, which is 10. So the real number on the left side equals the real number on the right side, thus confirming that x does equal 16. We'll then plug in 3 for y here and here, giving us 13 minus 3i, which would be 10i on the left side. And on the right side, we have 2 times 3, which is 6. 6 plus 4 would give us 10i. So the imaginary number on the right matches the imaginary number on the left, which confirms that y does equal positive 3. So the answer to question number 4 is x is equal to 16 and y is equal to 3. Let's take a look at question number 5. Find the sum of 5 plus 3i plus 6 plus 7i. Pause the video, answer this question, and then press play when you're ready to begin. Step 1, add the real numbers. So 5 plus 6 gives us 11 as our real number. Step 2, add the imaginary numbers. 3i plus 7i would give us 10i. So the sum of 5 plus 3i plus 6 plus 7i is equal to 11 plus 10i. Now let's have a look at question number 6. Find the sum of 7 plus 2i plus negative 3 minus 8i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add the real numbers. 7 plus negative 3 is equivalent to 7 minus 3, which would be positive 4. The second step, add the imaginary numbers. 2 plus negative 8i would be equal to negative 6i. So the sum of 7 plus 2i plus negative 3 minus 8i is equal to 4 minus 6i. Let's have a look at question number 7. Find the sum of negative 10 minus 5i plus 8 plus 4i. Pause the video, answer this question, and then press play when you're ready to begin. Step 1, add the real numbers. Negative 10 plus 8 is equal to negative 2. Step 2, add the imaginary numbers. Negative 5i plus 4i gives us negative I. So the sum of negative 10 minus 5i plus 8 plus 4i is equal to negative 2 minus I. Question number 8. Find the sum of 20 plus 7i plus negative 13 minus 10i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, add the real numbers. 20 plus negative 13 is equal to 7. Step 2, add the imaginary numbers. 7i plus negative 10i is equal to negative 3i. So the sum of 20 plus 7i plus negative 13 minus 10i is equal to 7 minus 3i. Let's now have a look at question number 9. Find the difference of 6 plus 10i minus negative 2 plus 7i. Pause the video, answer this question, and then press play when you are ready to begin. Our first complex number, 6 plus 10i, has a coefficient of positive 1. Anything times 1 is just itself, so we can bring down the first complex number without doing anything to it. Here, this negative is a negative 1 that needs to be distributed to both of these numbers in here. So that gives us negative 1 times negative 2, which is positive 2. Negative 1 times positive 7i gives us negative 7i. So we are left with 6 plus 10i plus 2 minus 7i. And now we'll want to combine our like terms. So our real numbers, we have 6 plus 2. And our imaginary numbers, we have 10i minus 7i. We are going to add these sums because we've already distributed our negative 1 for subtraction. So we do not need to put a negative 1 here. 6 plus 2 would give us 8, and 10i minus 7i gives us 3i. So the difference of 6 plus 10i minus negative 2 plus 7i is equal to 8 plus 3i. Question number 10. Find the difference of negative 3 minus 8i minus 10 minus 4i. Pause the video, answer this question, and then press play when you are ready to begin. So we bring down our first complex number, negative 3 minus 8i, and then we'll want to distribute the negative 1 that represents our subtraction to each of the two terms in the second complex number. Negative 1 times 10 is equal to negative 10. And negative 1 times negative 4i is equal to positive 4i. So after we distribute the negative 1, that represents our subtraction. We get negative 3 minus 8i minus 10 plus 4i. And now we want to combine the like terms. So we have negative 3 and negative 10 for our real numbers. So we'll combine those. And we'll add that to our imaginary numbers, negative 8i and positive 4i. And now once we combine these terms, we get negative 3 minus 10, which is negative 13. And we get negative 8i plus 4i, which is negative 4i. So the difference of negative 3 minus 8i minus 10 minus 4i is equal to negative 13 minus 4i. So that is the answer to question number 10. Let's now have a look at question number 11. Find the difference of 12 plus 7i minus negative 5 minus 7i. Pause the video, answer this question, and then press play when you are ready to begin. Since the coefficient of the first complex number is 1 times anything is just itself, so you bring down 12 plus 7i without doing anything to it. And you want to distribute the subtraction, or negative 1, to each of the terms in the second complex number. So we'll start there. Negative 1 times negative 5 is equal to positive 5. Negative 1 times negative 7i is equal to positive 7i. So we get 12 plus 7i plus 5 plus 7i. And now we will want to combine the like terms. So our real numbers, we have 12 and 5. And we add that to our imaginary numbers, 7i plus 7i. And now we can find the answer. 12 plus 5 is equal to 17, plus 7i plus 7i, which is 14i. So the difference of 12 plus 7i minus negative 5 minus 7i is equal to 17 plus 14i. So that's the answer to question number 11. Let's now have a look at question number 12. Find the difference of negative 15 minus 10i minus negative 11 plus 6i. Pause the video, answer this question, and then press play when you are ready to begin. So we can bring the first complex number down without doing anything to it. So we bring down negative 15 minus 10i. And we want to start by distributing this negative 1 to our second complex number. So negative 1 times negative 11 gives us positive 11. Negative 1 times positive 6i gives us negative 6i. So after the first step, we wind up with negative 15 minus 10i plus 11 minus 6i. And now we want to combine the like terms. So our real numbers are negative 15 and positive 11. And we add that to our imaginary numbers, negative 10i and negative 6i. Negative 15 plus 11 is equal to negative 4. Plus negative 10i minus 6i is negative 16i. So negative 15 minus 10i minus negative 11 plus 6i is equal to negative 4 minus 16i. So that is the answer to question number 12. Let's now have a look at question number 13. Find the product of 6 times negative 4 plus 5i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, distribute the 6 on the outside to each term inside the parentheses. When we do so, 6 times negative 4 is equal to negative 24. And 6 times 5i is equal to 30i. So we get a product of negative 24 plus 30i. So that is the answer to question number 13. Let's now have a look at question number 14. Find the product of negative 3 times 8 minus 7i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, distribute the negative 3 to each term inside the parentheses here. That would give us negative 3 times 8, which is negative 24. Negative 3 times negative 7i would give us positive 21i. So the product of negative 3 times 8 minus 7i is equal to negative 24 plus 21i. Let's take a look at question number 15. Find the product of 3 plus 5i times 2 minus 6i. Pause the video, answer this question, and then press play when you are ready to begin. Since we are multiplying two complex numbers, which are two binomials, they each have two pieces, we will need to use the FOIL method to expand this expression. So the F stands for first, so we'll multiply the first term in each complex number, which would be 3 times 2, which is equal to 6. We then multiply our outside terms. 3 times negative 6i gives us negative 18i. We then multiply our inside terms. 5i times 2 is equal to 10i. And then we multiply the last terms in each complex number. 5i times negative 6i gives us negative 30i squared. So using the FOIL method, we wind up with 6 minus 18i plus 10i minus 30i squared. So the next thing we want to do is replace the I squared here with negative 1. So we get negative 30 times negative 1, which would be equal to positive 30. And now we can combine our like terms. So for our real numbers, we have 6 and 30. And for our imaginary numbers, we have negative 18i and 10i. 6 plus 30 is equal to 36. Plus negative 18i plus 10i is negative 8i. So the product of 3 plus 5i times 2 minus 6i is equal to 36 minus 8i. So that is the answer for question number 15. Let's now have a look at question number 16. Find the product of negative 4 plus 7i times 8 minus 3i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, use the FOIL method to expand the expression. So F stands for first, so we'll multiply the first term in each complex number. So that gives us negative 4 times 8, which would be negative 32. We then want to multiply our outside terms, which gives us negative 4 times negative 3i, which would be positive 12i. We then want to multiply our inside terms. 7i times 8 would give us 56i. And then we want to multiply the last terms in each complex number, which would be 7i times negative 3i, which would give us negative 21i squared. And now we want to replace this I squared with negative 1. So that gives us negative 21 times negative 1. And that would be equal to positive 21. So now we have negative 32 plus 12i plus 56i plus 21. So for the third step, we want to combine the like terms. Our real number is negative 32 and positive 21. And our imaginary numbers, 12i and 56i, giving us negative 32 plus 21 is equal to negative 11, plus 12i plus 56i, which would be 68i. So the product of negative 4 plus 7i times 8 minus 3i is equal to negative 11 plus 68i. So that is the answer to question number 16. Let's now have a look at question number 17. Find the product of 4 minus 2i times 10 plus 3i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, use the FOIL method to expand the expression. So that would give us 4 times 10, which is equal to 40. 4 times 3i is equal to 12i. Negative 2i times 10 is equal to negative 20i. And negative 2i times 3i is equal to negative 6i squared. So after step 1, we have 40 plus 12i minus 20i minus 6i squared. So the next thing we want to do is replace the I squared with negative 1, giving us negative 6 times negative 1, and that would be positive 6. So now we want to combine the like terms. Our real numbers are 40 and 6, and our imaginary numbers are 12i and negative 20i. So now we can solve. 40 plus 6 is equal to 46, plus 12i minus 20i is equal to negative 8i. So the product of 4 minus 2i times 10 plus 3i is equal to 46 minus 8i. And that is the answer to question number 17. Let's now have a look at question number 18. Find the quotient of 4 divided by 2 minus 5i. Pause the video, answer this question, and then press play when you are ready to begin. So when you're dividing by a complex number, you want to multiply the numerator and the denominator by the conjugate of the denominator. The conjugate is the result of switching the sign between our real number and imaginary number from positive to negative, or in this case from negative to positive. So we will multiply the numerator 4 and the denominator 2 minus 5i by 2 plus 5i. When we multiply the numerator by the conjugate, we get 4 times 2, which gives us 8. 4 times 5i gives us 20i. So in the numerator, we have 8 plus 20i now. And now we multiply the denominator by the conjugate, giving us 2 times 2, which is 4. 2 times 5i is equal to 10i. Negative 5i times 2 is negative 10i. This negates positive 10i. And then we have negative 5i times positive 5i gives us negative 25i squared. So now we want to replace I squared with negative 1, giving us negative 25 times negative 1, which is positive 25. 25 plus 4 is equal to 29. So we wind up with 8 plus 20i over 29. And now we want to simplify this fraction. we want to break it up into two fractions, 8 over 29 plus 20i over 29. And since neither of these fractions can be simplified further, our final answer is 8 29ths plus 20i 29ths. So that is question number 18. Let's now have a look at question number 19. Find the quotient of 9 divided by -4 plus 8i. Pause the video, answer this question, and then press play when you are ready to begin. So we are going to multiply the numerator and denominator by the conjugate of the denominator. We are going to change the sign between our real number and imaginary number from positive to negative. So we'll be multiplying the numerator and denominator by -4 minus 8i. When we do so, we wind up with 9 times -4, which is equal to -36. Then we have 9 times -8i, which is -72i. And now the denominator, we get -4 times -4, which is positive 16. -4 times -8i gives us positive 32i. 8i times -4 is equal to -32i, which then negates positive 32i. And 8i times -8i gives us -64i squared. We want to replace this I squared with its equivalent -1. -64 times -1 gives us positive 64. 64 plus 16 is equal to 80. So after we multiply the numerator and denominator by the conjugate, we get -36 minus 72i divided by 80. And then we want to simplify this fraction. So we'll first break it up into two fractions, our real number and our imaginary number. So that gives us -36 over 80 minus 72i over 80. And now we can simplify it even further by simplifying each of these fractions. If we divide the numerator and denominator in the first fraction here by 4, we get 9 over 20. And in the second fraction, we can divide the numerator and denominator by 8, which would give us 9i over 10. So the final answer would be -9 over 20 minus 9i over 10. So that would be the answer to question number 19. Let's now have a look at question number 20. Find the quotient of 2 plus 3i divided by 4 minus 5i. Pause the video, answer this question, and then press play when you are ready to begin. Since our denominator is 4 minus 5i, we're going to multiply the numerator and denominator by the conjugate, which should be 4 plus 5i. When we do so, we get 2 times 4, which is equal to 8. 2 times 5i is equal to 10i. 3i times 4 is equal to 12i. And 3i times 5i is equal to 15i squared. We'll then multiply the denominator by the conjugate, giving us 4 times 4, which is equal to 16. 4 times 5i is equal to 20i. -5i times 4 is equal to -20i, which then cancels out the positive 20i. And -5i times 5i is equal to -25i squared. And now we want to replace each I squared here and here with -1, giving us 15 times -1, which is -15. and negative 25 times negative 1, which will give us positive 25. And now we have 8 plus 10i plus 12i minus 15 over 16 plus 25. So now we'll want to combine the like terms. In the numerator, we'll get 8 minus 15, which is negative 7. And 10i plus 12i would be 22i. Over 16 plus 25, which would be 41. So we get negative 7 plus 22i over 41. And the last step is to simplify the fraction. So we first want to break it up into two fractions, our real number and imaginary number, which would be negative 7 over 41 plus 22i over 41. And since neither of these fractions can be simplified further, this would be our final answer for question number 20. Negative 7 over 41 plus 22i over 41. So that's the answer for question number 20. Let's have a look at question number 21. Find the quotient of 6 minus 2i divided by 7 minus 6i. Pause the video, answer this question, and then press play when you are ready to begin. Since our denominator is 7 minus 6i, we want to multiply the numerator and denominator by the conjugate, which would be 7 plus 6i. When we do so, we wind up with 6 times 7, which is equal to 42. 6 times 6i would give us 36i. Negative 2i times 7 gives you negative 14i. Negative 2i times positive 6i gives us negative 12i squared. And now the denominator. 7 times 7 is 49. 7 times 6i is positive 42i. Negative 6i times 7 is negative 42i, which negates positive 42i. And negative 6i times 6i is equal to negative 36i squared. So now that we've expanded the numerator and denominator, we want to replace each of these I squareds with negative 1, giving us negative 12 times negative 1, which is positive 12. And negative 36 times negative 1 is positive 36. And now we can combine the like terms in the numerator and denominator. 42 plus 12 is 54. And 36i minus 14i would be 22i. And in the denominator, 49 plus 36 would be equal to 85. So that gives us 54 plus 22i over 85. So now the last step is to simplify this fraction. We'll first break it up into a real number and an imaginary number, giving us 54 over 85 plus 22i over 85. And since neither of these can be simplified further, we get our final answer to be 54 85ths plus 22i 85ths. So that is the answer to question number 21. Let's now have a look at question number 22. Find the quotient of 9 plus 8i divided by 2 plus 10i. Pause the video, answer this question, and then press play when you are ready to begin. Since the denominator is 2 plus 10i, the conjugate is the result of switching this addition to subtraction. So the conjugate is 2 minus 10i, which will multiply our numerator and denominator by, giving us 9 times 2, which is equal to 18. 9 times negative 10i is equal to negative 90i. 8i times 2 is 16i. And 8i times negative 10i is negative 80i squared. We now move to our denominator. 2 times 2 is equal to 4. 2 times negative 10i is negative 20i. 10i times 2 is positive 20i, which negates this negative 20i here. And 10i times negative 10i is negative 100i squared. We now want to replace this I squared and this I squared with negative 1, giving us negative 80 times negative 1, which is positive 80, and negative 100 times negative 1, which would be positive 100. And now we can combine the like terms. 18 plus 80 is 98, and negative 90i plus 16i is negative 74i. And in the denominator, 4 plus 100 is equal to 104. And now that we've combined the like terms, we now want to simplify the fraction. So we'll first start by separating this into two fractions, our real number and our imaginary number, giving us 98 over 104 minus 74i over 104. And now we can simplify these further. We can remove 2 from each of these values, leaving us with 98 over 2 is 49 over 52 minus 37i over 52. So the final answer to question number 22 is 49 50-seconds minus 37i 50-seconds. And that is the answer to question number 22. Let's now have a look at question number 23. Factor x squared plus 36 and check the answer. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, create two sets of parentheses. These are where our factors will go. In step 2, place a positive sign in one factor and a negative sign in the other factor. And now step 3, we will add the square root of the first term to the left side in each factor. The square root of x squared is equal to x, so we add x to each factor here. And now step 4, we'll add the square root of the second term, 36, to the right side in each factor. And the square root of 36 is equal to 6. And now step 5, we will multiply the number from step 4, which is our 6 here and here. And we'll multiply each of those by the imaginary unit I. So we see x squared plus 36 can be factored into x plus 6i times x minus 6i. In step 6, we can check the answer by multiplying the factors. The resulting polynomial should match the original polynomial, x squared plus 36. And when we multiply the factors, we get x times x, which is x squared. X times negative 6i is negative 6xi. 6i times x is positive 6xi, which negates negative 6xi. And 6i times negative 6i is equal to negative 36i squared. I squared is equal to negative 1. And negative 36 times negative 1 is equal to positive 36. So since our final polynomial matches the original polynomial, that confirms that x squared plus 36 can be factored into x plus 6i times x minus 6i. And that is the answer to question number 23. Let's now have a look at question number 24. Factor x squared plus 81 and check the answer. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, create two sets of parentheses. These are where our factors will go. Step 2, place a positive sign in one factor and a negative sign in the other factor. And now step 3, we will add the square root of the first term to the left side in each factor. The first term is x squared, and the square root of x squared would be x, so that's the first term in each factor. Step 4, add the square root of the second term to the right side in each factor. The second term is 81, and the square root of 81 is 9, so that's the second term in each factor. And now step 5, we want to multiply the number from step 4, which is the 9 in each factor, by the imaginary unit I, showing us that x squared plus 81 can be factored into x plus 9i times x minus 9i. In step 6, we will check the answer by multiplying the factors. The resulting polynomial must match the original polynomial. When we multiply the factors, we get x times x, which is x squared. X times negative 9i is negative 9xi. 9i times x is positive 9xi, which negates negative 9xi. 9i times negative 9i is negative 81i squared. I squared is equal to negative 1. And negative 81 times negative 1 is positive 81. Since our final polynomial matches the original polynomial, that confirms that x squared plus 81 can be factored into x plus 9i times x minus 9i. And that is the answer to question number 24. Let's now have a look at question number 25. Factor 4x squared plus 25 and check the answer. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, create two sets of parentheses. These are where our factors will go. And step 2, place a positive sign in one factor and a negative sign in the other factor. And now step 3, add the square root of the first term to the left side in each factor, giving us the square root of 4, which is 2, and the square root of x squared, which is x. So 2x is the first term in each factor. And now step 4, we'll add the square root of the second term, 25, to the right side in each factor. And the square root of 25 is equal to 5. So we add 5 to the right side in each factor. And then step 5, we'll multiply the 5 from our last step by the imaginary unit I, showing us that 4x squared plus 25 can be factored into 2x plus 5i times 2x minus 5i. In step 6, we can check the answer by multiplying the factors. The resulting polynomial must match the original polynomial, 4x squared plus 25. When we multiply the factors, we get 2x times 2x, which is 4x squared. We get 2x times negative 5i, which is negative 10xi. We get 5i times 2x, which is positive 10xi, which negates negative 10xi. 5i times negative 5i would give you negative 25i squared. I squared is equal to negative 1. And negative 25 times negative 1 is equal to positive 25. So since the final polynomial matches the original polynomial, that confirms that 4x squared plus 25 can be factored into 2x plus 5i times 2x minus 5i. And that is the answer to question number 25. Let's now have a look at question number 26. Factor 18x squared plus 98 and check the answer. Pause the video, answer this question, and then press play when you are ready to begin. Step 1. Remove a common factor from each term. The hint here is that neither the coefficient of the quadratic term nor our constant are perfect squares, so that's a clue that we'll need to remove a factor to create the sum of two perfect squares. And the factor we want to remove is 2, giving us 18 divided by 2, which is 9x squared, a perfect square. And 98 divided by 2 would give you 49, another perfect square. So now we have the sum of two perfect squares, so we can proceed to factor this portion of our expression the way we normally would. So step 2, we create two sets of parentheses where our factors will go. And step 3, place a positive sign in one factor and a negative sign in the other factor. And now step 4, we'll add the square root of the first term, 9x squared, to the left side in each factor, giving us the square root of 9, which is 3, and the square root of x squared, which is x. So we have 3x as the first part of each factor here and here. Step 5, we add the square root of the second term, 49, to the right side in each factor. The square root of 49 is 7, so we add 7 to each of these factors in the parentheses. And now step 6, we multiply our 7 from step 5 by the imaginary unit I, showing us that 18x squared plus 98 can be factored to 2 times 3x plus 7i times 3x minus 7i. In the last step, we can check the answer by multiplying the factors. The final polynomial that we get must match the original polynomial, 18x squared plus 98. When we multiply the factors, we get 3x times 3x, which is 9x squared. 3x times negative 7i is negative 21xi. 7i times 3x is positive 21xi, which cancels out negative 21xi. 7i times negative 7i is negative 49i squared. I squared is equal to negative 1. And negative 49 times negative 1 is positive 49. Now we distribute this 2, giving us 2 times 9x squared, which would be 18x squared. And 2 times 49 would be 98. Since the final polynomial matches the original polynomial, that confirms that 18x squared plus 98 can be factored into 2 times 3x plus 7i times 3x minus 7i. And that is the answer to question number 26. Let's now have a look at question number 27. Solve for x and check the answers. X squared minus 2x plus 10 is equal to 0. Pause the video, answer this question, and then press play when you are ready to begin. So for this question, since we are not able to factor this polynomial, we'll want to use the quadratic equation to solve for x. Remember, the quadratic equation is x is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2a. So we have three variables, a, b, and c. A is the coefficient of x squared, so a is equal to 1. B is equal to the coefficient of our x term, which would be negative 2. And c is our constant, which is 10. Make sure the right side is equal to 0. If there's a constant on the right side, you want to bring it over here and combine it with this one. But we have 0, so we're all set. So we have a is equal to 1, b is equal to -2, and c is equal to 10. So when we plug that into the quadratic formula, we get x is equal to -1 times -2 plus or minus the square root of -2 squared minus 4 times 1 times 10 divided by 2 times 1. And now we'll want to solve for x by simplifying this fraction. -1 times -2 is 2, divided by 2 times 1, which is 2, plus or minus the square root of -2 squared is 4, minus 4 times 1 times 10, which is minus 40, over 2. So now we have 2 over 2, which is equal to 1, plus or minus the square root of 4 minus 40, which would be -36 over 2. The square root of -36 is equal to the square root of 36 times the square root of -1, which is equal to 6i. 6 divided by 2 is equal to 3. So we get x is equal to 1 plus or minus 3i. And now we want to check these answers by plugging each number into the original equation, x squared minus 2x plus 10 is equal to 0. We'll start by plugging in the smaller value first, 1 minus 3i, and we'll plug it in for x here and here, giving us 1 minus 3i times 1 minus 3i minus 2 times 1 minus 3i plus 10 is equal to 0. We'll use the FOIL method to expand our x squared. 1 times 1 is equal to 1. 1 times -3i is -3i. -3i times 1 is -3i. And -3i times -3i is positive 9i squared. -2 times 1 is -2. -2 times -3i is positive 6i. Plus 10 is equal to 0. And now we get 1 minus 2, which is -1. -1 plus 10 is positive 9. We also have -3i minus 3i, which is -6i. We have positive 6i, so that comes down. And we have 9 times i squared, which is 9 times -1. So the -6i and the positive 6i cancel each other out, leaving us with 9 times -1, which is -9 plus 9. -9 plus 9 is equal to 0. 0 is equal to 0 confirms that x does equal 1 minus 3i. And now we'll test 1 plus 3i, and we'll plug it in for x here and here. We'll use the FOIL method to expand our x squared, giving us 1 times 1, which is 1. 1 times 3i is 3i. 3i times 1 is 3i. And 3i times 3i is 9i squared. -2 times 1 is -2. -2 times 3i is -6i. Plus 10 is equal to 0. Then we get 1 minus 2, which would be -1. Plus 10 would be positive 9. We have 3i and 3i, which is 6i. We have -6i. And then lastly, we have 9 times i squared, which is 9 times -1. 6i and -6i cancel each other out, leaving us with 9 times -1, which is -9, plus 9. -9 plus 9 is equal to 0. 0 is equal to 0 confirms that x is also equal to 1 plus 3i. So the answer to question number 27 is x is equal to 1 plus or minus 3i. Let's now have a look at question number 28. Solve for x and check the answers. X squared minus 4x plus 8 is equal to 0. Pause the video, answer this question, and then press play when you are ready to begin. So for this expression, we have x squared minus 4x plus 8 is equal to 0. Our a is equal to the coefficient of x squared, which is 1. Our b is the coefficient of our x term, which is negative 4. And our c is the constant, which is positive 8. And we want to plug a, b, and c into the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c over 2a. So when we plug in a, b, and c, we get x is equal to negative 1 times negative 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 8 divided by 2 times 1. And now we can solve for x by simplifying this. Negative 1 times negative 4 is positive 4, divided by 2 times 1, which is 2, plus or minus the square root of negative 4 squared, which is 16, minus 4 times 1 times 8, which is minus 32, divided by 2 times 1, which is 2. So that leaves us with x is equal to 4 over 2, which is 2, plus or minus the square root of 16 minus 32, which is negative 16 over 2. The square root of negative 16 is equal to the square root of 16 times the square root of negative 1. The square root of 16 is 4, and the square root of negative 1 is I. 4 divided by 2 is equal to 2. So we get x is equal to 2 plus or minus 2i. And now we want to check the answers by plugging each number into the original equation. X squared minus 4x plus 8 is equal to 0. We'll start by plugging in the smaller value, 2 minus 2i, and we'll plug it in here and here, giving us 2 minus 2i times 2 minus 2i minus 4 times 2 minus 2i plus 8 is equal to 0. We'll use the FOIL method to expand x squared. 2 times 2 is 4. 2 times negative 2i is negative 4i. Negative 2i times 2 is negative 4i. Negative 2i times negative 2i is positive 4i squared. Negative 4 times 2 is negative 8. Negative 4 times negative 2i is positive 8i. Plus 8 is equal to 0. Negative 4i minus 4i is negative 8i. Positive 8i we have. Those two will cancel each other out, leaving us with 4 minus 8, which is negative 4. Plus 8 would give us positive 4 here. And that just leaves 4 times I squared, which is 4 times negative 1. 4 times negative 1 is negative 4 plus 4, and that would be equal to 0. So when x is equal to 2 minus 2i, the left side equals the right side, which confirms that 2 minus 2i is a value of x. And now we test our second value, 2 plus 2i, giving us 2 times 2, which is 4. 2 times 2i is 4i. 2i times 2 is 4i. 2i times 2i is 4i squared. Negative 4 times 2 is negative 8. Negative 4 times 2i is negative 8i. Plus 8 is equal to 0. 4i and 4i give you 8i. And we have negative 8i. So these two wind up canceling each other out, leaving us with 4 minus 8, which is negative 4, plus 8 would give us positive 4. And we have 4 times I squared, which is 4 times negative 1, which is negative 4, plus 4. And when we combine these two, we get 0. So 0 is equal to 0 confirms that x also equals 2 plus 2i. So the answer to question number 28 is x is equal to 2 plus or minus 2i. And now let's have a look at question number 29. Solve for x and check the answers. 2x squared minus 6x plus 5 is equal to 0. Pause the video, answer this question, and then press play when you are ready to begin. So we have 2x squared minus 6x plus 5 is equal to 0. So the coefficient of x squared is 2, so that's our a. The coefficient of x is negative 6, so that's our b. And we have a constant of positive 5, so that is our c. And now we plug a, b, and c into the quadratic formula, and we get x is equal to negative 1 times negative 6 plus or minus the square root of negative 6 squared minus 4 times 2 times 5 divided by 2 times 2. And we solve for x by simplifying this. Negative 1 times negative 6 is positive 6 divided by 2 times 2, which is 4, plus or minus the square root of negative 6 squared is 36, minus 4 times 2, which is 8. 8 times 5 is 40, so we get minus 40 over 4. 6 over 4 is equivalent to 3 over 2, plus or minus the square root of 36 minus 40 is the square root of negative 4, divided by 4. The square root of negative 4 is equal to the square root of 4 times the square root of negative 1. And those are equivalent to 2i. 2 divided by 4 is equal to 1/2. So we get x is equal to 3/2 plus or minus I over 2. And now we want to check the answers by plugging each number into the original equation. So we'll first plug in 3/2 minus I over 2 in for x. And then we'll plug in 3/2 plus I over 2 in for x. So when we plug in the smaller number of the two, 3/2 minus I over 2, we'll plug them in for x here and here, leaving us with 2x squared minus 6 times x plus 5 is equal to 0. So if we multiply our x's here, 3/2 minus I over 2 times 3/2 minus I over 2, we get 3/2 times 3/2, which is 9 over 4. Then we get 3/2 times negative I over 2, which is 3 times I, 3i, over 2 times 2, which is 4. And we have the negative. Then we have negative I over 2 times 3/2, which is negative I times 3, which is negative 3i, over 2 times 2, which is 4. Then we have negative I times negative I, which is positive I squared, over 2 times 2, which is 4. We distribute our negative 6 to 3/2 minus I over 2 here, giving us negative 6 times 3, which is negative 18 over 2. And we have negative 6 times negative I, which is positive 6i over 2. Plus 5 is equal to 0. So we'll start here. Negative 18 over 2 is negative 9, and 6i over 2 is 3i. Negative 9 plus 5 is equal to negative 4. So now we start working on this part of our expression. So we begin by distributing this 2 to each term inside of the parentheses. When we do so, we get 2 times 9, which is 18 over 4. 2 times negative 3i is negative 6i over 4. 2 times negative 3i is negative 6i over 4. 2 times negative 1, I squared is negative 1, gives us negative 2 over 4. Minus 4 plus 3i is equal to 0. And now we simplify this even further. 18 over 4 minus 2 over 4 will give us 16 over 4. And negative 6i over 4 minus 6i over 4 will give us negative 12i over 4. Negative 12i over 4 is equal to negative 3i. 16 over 4 is equal to 4. Negative 3i and positive 3i cancel each other out. And 4 minus 4 is equal to 0 as well, giving us 0 is equal to 0, thus confirming that x does equal 3/2 minus I over 2. And now let's check the second value of x, 3/2 plus I over 2. So we have 2x squared minus 6x plus 5 is equal to 0. So if we use the FOIL method to expand our x squared, we get 3 times 3, which is 9, over 2 times 2, which is 4. Then we have 3 times I, which is 3i, over 2 times 2, which is 4. Then we have I times 3, which is 3i, over 2 times 2, which is 4. Then we have I times I, which is I squared, over 2 times 2, which is 4. Over here, minus 6x, we have negative 6 times 3, which is negative 18, over 2, which is here. Negative 6 times I is negative 6i over 2, plus 5 is equal to 0. So negative 18 over 2 is equivalent to negative 9, and negative 6i over 2 is equivalent to negative 3i. Negative 9 plus 5 is equivalent to negative 4. So now we can expand this part of our expression here by distributing 2 to each of these terms. When we do so, we get 2 times 9, which is 18, over 4. We get 2 times 3i, which is 6i, over 4. 2 times 3i is 6i, over 4. And 2 times negative 1 is negative 2, over 4. Minus 4 minus 3i is equal to 0. 18 over 4 minus 2 over 4 is equal to 16 over 4. And 6i plus 6i is equal to 12i over 4. 12i over 4 is equal to 3i. And 16 over 4 is equal to 4. 3i minus 3i gives you 0. 4 minus 4 gives you 0. So we get 0 on the left side, which is equal to 0 on the right side, thus confirming that x is also equal to 3/2 plus I over 2. So the answer to question number 29 is x is equal to 3/2 plus or minus I over 2. Let's have a look at question number 30. Solve for x and check the answers. 2x squared plus 2x plus 1 is equal to 0. Pause the video, answer this question, and then press play when you are ready to begin. So we have 2x squared plus 2x plus 1 is equal to 0. So our a is equal to 2, the coefficient of x squared. Our b is also equal to 2, the coefficient of our x term. And c is equal to 1, our constant. And we plug a, b, and c into our quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. Plug a, b, and c in, and we get x is equal to negative 1 times 2 plus or minus the square root of 2 squared minus 4 times 2 times 1 over 2 times 2. Now we can solve for x by simplifying this expression. So we get negative 1 times 2, which is negative 2 divided by 2 times 2, which is 4, plus or minus the square root of 2 squared, which is 4, minus 4 times 2 times 1, which gives you minus 8 over 4. So we get negative 2 over 4, which is negative 1/2, plus or minus the square root of 4 minus 8, which is negative 4 over 4. The square root of negative 4 is equal to the square root of 4 times the square root of negative 1. The square root of 4 is equal to 2, and the square root of negative 1 is I. 2 divided by 4 is equal to 1/2, so we get x is equal to negative 1/2 plus or minus I over 2. And now to check the answers, we plug each number into the original equation. So we'll test negative 1/2 minus I over 2 first. We'll plug it in for x here and here, giving us 2 times negative 1/2 minus I over 2 times negative 1/2 minus I over 2 plus 2 times negative 1/2 minus I over 2 plus 1 is equal to 0. We'll use the FOIL method to expand our x squared, giving us negative 1 times negative 1, which is positive 1, over 2 times 2, which is 4. Then we have negative 1 times negative I, which is positive I, over 2 times 2, which is 4. And now we multiply this term here times each of these. So we get negative I times negative 1, which is positive I, over 2 times 2, which is 4. Then it's negative I times negative I, which is positive I squared, over 2 times 2, which is 4, plus 2 times negative 1, which is negative 2 over 2, here. 2 times negative I is negative 2I over 2, plus 1 is equal to 0. Negative 2 over 2 is negative 1, and negative 2I over 2 is negative I. Negative 1 cancels out positive 1. And now we can expand this part of our expression by distributing the 2 to each term inside the parentheses, giving us 2 times 1, which is 2 over 4. 2 times I, which is 2I over 4. 2 times I gives us 2I over 4. And 2 times negative 1 is negative 2 over 4. Minus I is equal to 0, giving us 2 over 4 minus 2 over 4, so those cancel each other out. And we have 2I plus 2I, which is 4I over 4. 4 divided by 4 is 1, giving us 1 times I, which is I. I minus I is equal to 0. So we get 0 is equal to 0, confirming that x does equal negative 1/2 minus I over 2. And now we test the second value, negative 1/2 plus I over 2. We'll expand the x squared first. Negative 1 times negative 1 is 1 over 2 times 2, which is 4. Negative 1 times I gives you negative I over 2 times 2, which is 4. I times negative 1 is negative I over 2 times 2, which is 4. I times I gives you I squared over 2 times 2, which is 4. Then we have 2 times negative 1, which is negative 2 over 2. Then we have 2 times I, which is 2I over 2. Plus 1 is equal to 0. Negative 2 over 2 is equal to 1. And 2I over 2 is equal to I. Negative 1 cancels out positive 1. And now we can expand this part of our expression. 2 times 1 is 2 over 4. 2 times negative I is negative 2I over 4. 2 times negative I is negative 2I over 4. 2 times negative 1 is negative 2 over 4. Plus I is equal to 0, giving us 2 over 4 minus 2 over 4, so those cancel each other out. And negative 2I minus negative 2I over 4 gives us negative 4I over 4. This would give us negative I. Negative I plus I is equal to 0. And this confirms that x also equals negative 1/2 plus I over 2. So the answer to question number 30 is x is equal to negative 1/2 plus or minus I over 2. And let's now have a look at question number 31. Find the modulus of 4 plus 7i. Pause the video, answer this question, and then press play when you are ready to begin. So the formula for the modulus, r, is equal to the square root of a squared plus b squared. A is the real number in the complex number, and b is the imaginary number in the complex number. So step 1, square the real number, which in this case is 4. So we'll do that first, 4 squared. Then the second thing you want to do is square the imaginary number, which is 7. So we have 7 squared. And we want to add these squares together. And then the fourth step is to find the square root, giving us r is equal to the square root of 4 squared, which is 16, plus 7 squared, which is 49. 16 plus 49 is equal to 65. So the modulus of 4 plus 7i is equal to the square root of 65. Let's have a look at question number 32. Find the modulus of negative 2 plus 6i. Pause the video, answer this question, and then press play when you are ready to begin. So we have the complex number negative 2 plus 6i. The first thing we want to do is square the real number negative 2, giving us negative 2 squared. Then the next thing we want to do is square the imaginary number 6, giving us 6 squared. And then we add those squares together and then find the square root. So the modulus r is equal to negative 2 squared, which is 4, plus 6 squared, which is 36. 4 plus 36 is equal to 40. This can be simplified further. The square root of 40 is equal to the square root of 4 times the square root of 10. The square root of 4 is equal to 2. So the modulus of negative 2 plus 6i is equal to 2 radical 10. Let's have a look at question number 33. Find the modulus of 2 times 5 minus 3i plus I. Pause the video, answer this question, and then press play when you are ready to begin. So we want to take the expression and expand it and then simplify it into a complex number. Then we can use our formula for the complex number to find the modulus. So we first want to distribute the 2 on the outside of the parentheses to both numbers inside of the parentheses, giving us 2 times 5, which is 10, and 2 times negative 3i, which is negative 6i, plus I. Negative 6i plus I is equal to negative 5i. So 2 times 5 minus 3i plus I is equal to 10 minus 5i. So now we can use our modulus formula. The modulus is equal to the square root of the real number squared plus the imaginary number squared. So we'll square the real number 10, giving us 10 squared. And we'll square the imaginary number negative 5 to give us negative 5 squared. We'll add the squares together and find the square root, giving us r is equal to the square root of 10 squared, which is 100, plus negative 5 squared, which is 25. 100 plus 25 gives us 125, and the square root of 125 can be simplified further by breaking it up into the square root of 25 times the square root of 5. And the square root of 25 is equal to 5. So the modulus of 10 minus 5i is equal to 5 radical 5. Let's take a look at question number 34. Find the modulus of negative 3 times 4 minus 2i minus 2i. Pause the video, answer this question, and then press play when you are ready to begin. First, we want to distribute the negative 3 to each term inside here, giving us negative 3 times 4, which is negative 12. Negative 3 times negative 2i is positive 6i minus 2i. 6i minus 2i is equal to 4i. So negative 3 times 4 minus 2i minus 2i is equal to negative 12 plus 4i. So now that we have it simplified into a complex number, we can use our formula for modulus. R is equal to the square root of the real number squared plus the imaginary number squared. So we want to square the real number negative 12. And we want to square the imaginary number 4. And then once we do that, we want to add the squares together and then find the square root, giving us the modulus is equal to the square root of negative 12 squared, which is 144, plus 4 squared, which is 16. 144 plus 16 is equal to 160, and the square root of 160 can be simplified further by breaking this up into the square root of 16 times the square root of 10. The square root of 16 is equal to 4, giving us the modulus is equal to 4 radical 10. Let's now have a look at question number 35. Find the argument of 3 plus 6i. Pause the video, answer this question, and then press play when you're ready to begin. First, let's sketch our right triangle for this complex number. So step 1, go to 3 on the real axis. Step 2, draw a dotted line up to 6 on the imaginary axis, and then plot the point that represents 3 plus 6i. From here, we can draw a line to the origin. So now we have the right triangle that we can use to calculate our argument, which is the angle closest to the origin here. The argument is equivalent to this angle theta. So theta has an adjacent side equal to 3 and an opposite side equal to 6. So we can use this information to find the inverse tangent of 6 over 3. Remember tangent, or TOA in SOHCAHTOA. TOA. TOA is the tangent of the angle, is equivalent to the opposite side over the adjacent side. So the inverse tangent gives us the angle itself. So we'll plug in the inverse tangent of 6 over 3 into a calculator in degrees mode, and we'll get theta is equal to 63 degrees. And if we want this answer in radians, then we multiply it times pi over 180 degrees. Remember, 1 radian is equal to 180 degrees. So pi over 180 degrees is equal to 1. So we're not changing the value, we're changing how we represent it from degrees to radian. So 63 degrees divided by 180 degrees gives us 0.35 radian. So the answer to question number 35 is 63 degrees and 0.35 radian. Let's now have a look at question number 36. Find the argument of 5 plus 8i. Pause the video, answer this question, and then press play when you are ready to begin. So we'll start by drawing the right triangle that we need to help solve for the argument for 5 plus 8i. So step 1, go to 5 on the real axis. Step 2, draw a dotted line up to 8 on the imaginary axis and then plot the point. And from here we draw a line to the origin. The angle closest is theta, which represents our argument. Remember, the argument is the angle from the positive real axis to the vector of our modulus here. And now, if this is our theta, then that means the adjacent side to theta has a length of 5. The real number is 5. And theta has an opposite side equal to 8, the imaginary number. So finding the inverse tangent of theta would be the opposite side over adjacent side, which is 8 over 5. If we plug that into a calculator in degrees mode, theta is equal to the inverse tangent of 8 over 5. Then we get theta is equal to 58 degrees. And if we want this answer in radian form, then we want to multiply it times pi over 180 degrees. 58 degrees divided by 180 degrees gives 0.32 radian. So the answer to question number 36 is 58 degrees or 0.32 radian. Question number 37. Find the argument of 2 plus 7i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to 2 on the real axis. Step 2, draw a dotted line up to 7 on the imaginary axis and then plot the point. You then want to draw a line from the point to the origin, giving us our right triangle for 2 plus 7i. The angle closest to the origin here is our argument, or theta. And if that's our theta, we see that the side adjacent to theta is equal to 2, the real number. And the side opposite of theta is equal to 7, the imaginary number. So finding the inverse tangent of theta gives us the opposite side over the adjacent side, which is 7 over 2. So if we find the inverse tangent of 7 over 2, that will give us this angle here, theta, our argument. If we plug in the inverse tangent of 7 over 2 into a calculator in degrees mode, we get theta is equal to 74 degrees. And if we want this answer in radian form, we want to multiply it times pi over 180 degrees. 74 degrees divided by 180 degrees gives us 0.41 radian. So the answer to number 37 is 74 degrees, or 0.41 radian. Let's now have a look at question number 38. Find the argument of -3 plus 7i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to -3 on the real axis. Step 2, draw a dotted line up to 7 on the imaginary axis, and then plot the point. This point represents our complex number, -3 plus 7i. And from that point, you want to draw a line to the origin. This gives us the right triangle that we are going to use to help us calculate the argument, which is the angle from the positive real axis to the vector of the modulus. This angle closest to the origin is not theta in the second quadrant, it is alpha. And if this is alpha, then the adjacent side to alpha in our right triangle is equal to 3. The net distance of the side is 3. And the side opposite is 7. And we're going to use the inverse tangent of alpha to calculate this angle. And then we'll subtract that angle from 180 degrees, which will give us the remainder of this angle here, which will be the argument theta. Where we have a straight line, 180 degrees. We'll find out alpha, subtract it, and what's left is our argument. So the inverse tangent of the alpha angle is equal to the inverse tangent of 7 over 3. So if we plug that into a calculator in degrees mode, we'll find out the alpha angle in degrees. So the inverse tangent of 7 over 3 shows us that the alpha angle is equal to 67 degrees. We'll now subtract that from 180 degrees, giving us our argument, or theta, is equal to 113 degrees. And if we want this answer in radian form, then we want to multiply it by pi over 180 degrees. 113 degrees divided by 180 degrees is equal to 0.63 radian. So the answer to question number 38 is 113 degrees, or 0.63 radian. Let's take a look at question number 39. Find the argument of -4 plus 12i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to -4 on the real axis. Step 2, draw a dotted line up to 12 on the imaginary axis, and then plot the point here. This point represents our complex number, -4 plus 12i. And from here, we want to draw a line to the origin. The angle closest to the origin on the inside of this right triangle is our alpha angle. And if this is our alpha angle, then it has an adjacent side equal to 4 and an opposite side equal to 12. So if we find the inverse tangent of this angle, it'll be the opposite side 12 over the adjacent side 4. That will give us this alpha angle, which will then allow us to calculate the argument or theta. So if we plug in the inverse tangent of 12 over 4 into a calculator in degrees mode, then the alpha angle would be equal to 72 degrees. And now we want to subtract that from 180 degrees, giving us the argument or theta is equal to 108 degrees. And if we want this answer in radian form, then we want to multiply it times pi over 180 degrees. 108 degrees divided by 180 degrees gives us 0.6 radian. So the answer to question number 39 is 108 degrees or 0.6 radian. Let's have a look at question number 40. Find the argument of -5 plus 8i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to -5 on the real axis. In step 2, draw a dotted line up to 8 on the imaginary axis and then plot the point. From here, draw a line to the origin. This gives you the right triangle we need to use to find our argument. The angle on the inside closest to the origin is our alpha angle. And if this is our alpha angle, then the adjacent side is equal to 5 and the opposite side is equal to 8. And once we find alpha, then we subtract it from 180 to give us our argument or theta. So what we do is we plug in the inverse tangent of 8 over 5, opposite over adjacent, into a calculator in degrees mode. And the inverse tangent of 8 over 5 gives us alpha is equal to 58 degrees. We'll then subtract that from 180 degrees. And 180 degrees minus 58 degrees shows us that the argument or theta is equal to 122 degrees. And now if we want this answer in radian form, we'll multiply it times pi over 180 degrees. 122 degrees divided by 180 degrees gives us the argument or theta is equal to 0.68 radian. So the answer is 122 degrees or 0.68 radian. Let's have a look at question number 41. Find the argument of -4 minus 6i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to -4 on the real axis. Step 2, draw a dotted line down to -6 on the imaginary axis, and then plot the point that represents our complex number, -4 minus 6i. From the point, we want to draw a line to the origin. This gives us the right triangle that we'll use to calculate our argument. Now we're working in the third quadrant. The angle on the inside of this right triangle closest to the origin is our alpha angle. And if this is alpha, the side adjacent here has a total length of 4 and has an opposite side equivalent to 6. Remember, the length is 6, although the complex number has an imaginary number of -6. So we'll find the inverse tangent, which will be the inverse tangent of 6 over 4, and that will give us our alpha angle. We'll then subtract that from 180, and that will give us negative theta. We'll then multiply that number times -1 to get our theta, or argument. Remember, in quadrants 3 and 4, the argument is always going to be negative, since we are now moving in the opposite direction to calculate the argument. So we'll find the inverse tangent of this angle, which will be the inverse tangent of 6 over 4. Plug that into a calculator, and we get alpha is equal to 56 degrees. If we subtract that from 180 degrees, we'll get negative theta. 180 degrees minus 56 degrees is equal to 124 degrees. Our argument will always be negative in the third quadrant. So we want to multiply both sides by -1 to get just theta, get rid of this negative. So what we'll do is we'll multiply negative theta by -1, and we'll multiply the other side by -1 as well, giving us theta is equal to 124 degrees times -1, which shows us that theta is equal to -124 degrees. And if we want this answer in radian form, then we'll multiply it by pi over 180 degrees. And -124 degrees divided by 180 degrees gives us -0.69 radian. So the argument for -4 minus 6i is -124 degrees, or -0.69 radian. Question number 42. Find the argument of -5 minus 3i. Pause the video, answer this question, and then press play when you're ready to begin. Step 1, go to -5 on the real axis. In step 2, draw a line down to -3 on the imaginary axis and then plot the point. This point represents -5 minus 3i. And from here we want to draw a line to the origin. The angle on the inside of this triangle is our alpha angle. So we will use the side opposite of our alpha angle, which has a length of 3, and the side adjacent, which has a length of 5, to help us calculate alpha. And then once we calculate alpha, we can then calculate theta by subtracting alpha from 180 and then multiplying that difference times -1. So to calculate the alpha angle, we'll find the inverse tangent of the opposite side over the adjacent side, which would be 3 over 5. When we plug in the inverse tangent of 3 over 5 into our calculator in degrees mode, we see that the alpha angle is equal to 31 degrees. We then want to subtract 31 degrees from 180 degrees to give us negative theta. 180 degrees minus 31 degrees is equal to 149 degrees. This is our negative theta, because our argument is always going to be negative in the third quadrant. So we multiply negative theta and 149 degrees times -1, giving us theta is equal to 149 degrees times -1, which shows us that the argument, or theta, is equal to -149 degrees. And to convert this answer into radians, you want to multiply it times pi over 180 degrees. Doing so gives you negative 149 degrees divided by 180 degrees, which gives you negative 0.83 radian. So the argument of negative 5 minus 3i is negative 149 degrees, or negative 0.83 radian. Let's have a look at question number 43. Find the argument of negative 2 minus 7i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to negative 2 on the real axis. And then step 2, draw a dotted line down to negative 7 on the imaginary axis, and then plot the point. This point represents negative 2 minus 7i. And from here, you want to draw a line to the origin. We can now use this right triangle to help us solve for our theta angle. But first, we'll solve for the alpha angle, which is the angle closest to the origin on the inside of our right triangle here. So we'll use this angle. The adjacent side has a length of 2. The opposite side has a length of 7. So we'll use those to find the inverse tangent of this angle. And then we'll subtract that angle from 180 degrees. And then multiply that number times negative 1 to give us our theta angle. When we do so, we'll plug in the inverse tangent of the opposite side 7 over the adjacent side 2 into a calculator in degrees mode. And the inverse tangent of 7 over 2 would give us that alpha is equal to 74 degrees. You now want to subtract 74 degrees from 180 degrees. 180 degrees minus 74 degrees is 106 degrees. We now want to multiply negative theta times negative 1. So we multiply both sides by negative 1 so that we get just theta. And that is equal to 106 degrees times negative 1, which shows us that the argument, or theta, is equal to negative 106 degrees. And if we want this answer in radian form, we want to multiply it times pi over 180 degrees, giving us negative 106 degrees divided by 180 degrees, which would be negative 0.59 radian. So the argument of negative 2 minus 7i is negative 106 degrees, or negative 0.59 radian. Let's have a look at question number 44. Find the argument of 4 minus 10i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to 4 on the real axis. Step 2, draw a dotted line down to negative 10 on the imaginary axis, and then plot the point. This point represents our complex number, 4 minus 10i. And from the point, we want to draw a line to the origin. This gives us the right triangle that we'll use to calculate our argument. And the angle on the inside of this right triangle is our argument, or theta, in the fourth quadrant. So if this is our theta, or argument, then the side adjacent to it has a total length of 4, and the side opposite has a total length of 10. So to calculate theta, we'll need the inverse tangent of the opposite side 10 over the adjacent side 4. So if we plug that into a calculator in degrees mode, we get the inverse tangent of 10 over 4, gives us negative theta is equal to 68 degrees. Remember, this is negative theta because in the fourth quadrant, our theta is going to be negative. So we multiply both sides by negative 1, and that shows us that the argument, or theta, is equal to 68 degrees times negative 1, which means theta is equal to negative 68 degrees. And if we want this answer in radian form, then we want to multiply it by pi over 180 degrees. Negative 68 degrees divided by 180 degrees gives us negative 0.38 radian. So the argument of 4 minus 10i is negative 68 degrees, or negative 0.38 radian. Question number 45. Find the argument of 6 minus 9i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to 6 on the real axis. Step 2, draw a dotted line down to negative 9 on the imaginary axis and then plot the point. This represents our complex number 6 minus 9i. And from here we want to draw a line from the point to the origin. The angle on the inside of this right triangle is the argument or theta that we are looking for. And if this is theta, then the adjacent side has a total length of 6 and the opposite side has a total length of 9. So if we want to calculate this angle theta, then we'll need to find the inverse tangent of 9 over 6 in a calculator in degrees mode. We plug in the inverse tangent of 9 over 6 into our calculator and we get negative theta is equal to 56 degrees. We now want to multiply negative theta by negative 1 so that we get just theta. So theta is equal to 56 degrees times negative 1, which shows us that the argument or theta is equal to negative 56 degrees. And if we want this answer in radian form, then we want to multiply it times pi over 180 degrees, giving us negative 56 degrees divided by 180 degrees, which is negative 0.31 radian. So the argument of 6 minus 9i is negative 56 degrees, or negative 0.31 radian. And let's have a look at the last question of this practice set, number 46. Find the argument of 7 minus 2i. Pause the video, answer this question, and then press play when you are ready to begin. Step 1, go to 7 on the real axis. Step 2, draw a dotted line down to negative 2 on the imaginary axis and then plot the point. This represents 7 minus 2i. From the point, we want to draw a line to the origin, and the angle on the inside of this right triangle is our theta, or our argument. So if this angle is theta, that means the side adjacent to it has a total length of 7, and the side opposite of it has a total length of 2. So to find this angle, we'll do the inverse tangent of the opposite side 2 over the adjacent side 7. So when we plug in the inverse tangent of 2 over 7 into a calculator in degrees mode, we get negative theta is equal to 16 degrees. To get just theta, we want to multiply both sides by negative 1, giving us theta is equal to 16 degrees times negative 1, which shows us that the argument, or theta, is equal to negative 16 degrees. And to convert this answer into radian form, you'll want to multiply it times pi over 180 degrees, giving you negative 16 degrees divided by 180 degrees is negative 0.09 radian. So the argument of 7 minus 2i is negative 16 degrees, or negative 0.09 radian. And that wraps up practice set number 1 to our complex numbers chapter. Should you have any follow-up questions, feel free to leave them in the comment section, or you can contact a tutor in your neighborhood by visiting bookandtable.com or by downloading our app on the App Store. Peace.